Greetings, everyone. Welcome to this dev pairing session. I'm Alex Shiel, as always, working at GitLab on OpenBao. And I have with me today, Jonas. Would you like to introduce yourself?
Sure. Hi, I'm Jonas. I'm a software engineer at Reply. We're an IT consultancy, and we've been fortunate to be contracted by SAP actually to work on OpenBao in an open source project. So I've been getting into it for the past 2 weeks, you could say. And it's been quite interesting to explore the code base. It's quite complex, but that's where the challenge is. That's where the fun is.
Indeed. I think I looked recently, and we're at somewhere north of 400,000 lines of code in the main repository. So we have a fair bit of fun here. So today we'll be working on the namespaces RFC. For anyone not aware, we have this OpenRFC 787. In our last video, worked on a portion of that, cleaning up request handling. Today, we're going to move on to a little different subportion, which is that we need a couple of mounts provisioned within each namespace by default. Two of them will be, for lack of a better word, actual mounts. Cubbyhole and token will be mounted within each namespace and visible in the mount table. But the sys handler also needs to be mounted within the namespace so that it's accessible. We're creating child namespaces eventually, and modifying other namespace specific stuff. But sys doesn't typically show up in mount table lists, unlike cubbyhole and token. So this portion is what we'll be working on today. Let's start by creating a new branch. I mentioned this last time, and so I guess I'll keep mentioning it every time, but if you see shell aliases that I'm using and want to take a look at them further, I have a .files repo on my personal GitHub. So cipherboy/.files, and if you're wondering what GTOB is, it checks out a branch. If you're looking for those are there. So let's see. Mount sys friends. Sure. Cool. So I think where we're at is within the vault space. We have the namespace store. Construct that actually does our creation and stuff. And so right now we don't have any, we need to start thinking about what happens when we create a namespace, I think, Jonas. We have 3 things that we kind of need to mount into that. And so we'll need to create mount table entries as well for that, and modify the mount loading code. But then we'll leave delete cleanup, I think, to Andri to deal with later. So I think set namespace locked is what we call to actually do the creation. And yes. I don't think
I think it's also called by the loading code. So if we're lucky, we can have the entire mounting in one place.
Yeah, we need to separate off creating the storage entries corresponding with the token and code first, and then also create the you're right, the mount table adjustment, the live mount table adjustment to add in sys. So let's go look at that first. I guess I should double check. I think I have a node running around. Oh, I guess sys is already actually shows up in the secret list. So I guess we'll be mounting 3 of them then. more explicitly, we'll be listing cubbyhole, system, and token. So if we look at sysraw core mounts, we have 1, 2, 3, 4, 5, 6 items here, and we have 5 items here. So I suspect, though, sys isn't explicitly shown in this in the table-based version, but is present in oh no, sys is present. So what's short? Cubbyhole is the magic one. I see. So we'll write storage entries for sys and for token auth, and then we'll magically handle cubbyhole if necessary for namespaces. So very good. So we kind of need a flag in here, I guess. I guess we have that with ID or with index. For modification purposes, if index is not -1, we probably want to verify, because I don't think we support a remount operation for namespaces, do we? If we look at like patch or create namespace, this is strictly path is given here, and there's no new path parameter.
Yeah. Funnily enough, in the current code, we are resetting the path in the create namespace API, but I don't think there's a way it could modify it to a new value.
Yes, and we also don't in the remount API, we also do not support remounting namespaces. We only support remounting secret engines and auth engines. So we don't need to support the rename operation, so we should probably add that while we're here. Index.path not equals entry.path. Cool. Very good. So then if we have a new namespace, then we should probably call something like create mounts with their context and entry. And otherwise, we should not need to they should already exist. And we're creating sys and token runs namespace. Good. So I guess we're somewhere down here. And let's see, so we need to create mounts. This is the namespace entry. I think we probably just need to return an error. So within mount.go, I believe, mount internal is, or mount rather is used to mount a new namespace or a new backend to the namespace. And we do keep our reference to core. So we probably just want to call mount here. But I think we'll need to adjust our context a little bit first. So that it's a consistent path, right? Namespace with context with namespace. And then this is ctx and entry namespace, I believe. Oops. So it's return in there. God. No, this returns the namespace. Cool. No, entry.
Right, so to understand, the request to create the namespace might have come from the root namespace maybe, and then in this case we have to manually set it to already be the created namespace such that we then mount at the right point.
Correct. Yep. Context may have a namespace of the parent. New context of the Java namespace. Cool. Yep, and so that's exactly right. And so now we need to figure out what it is we want to mount here. And if we look at this, so a table that this will assign to, let's see what file mount.go. This is in the, let's see, what do I have options for mount table type? I think this is mount table type for sys. And then I know I want mount type namespace system at some point. Let's see, path. I assume mount path is not the full path. I think it is just the I assume it is just the relative path, but we shall see later what breaks. We want a system type. Yes, description. Let's see, prod. This one, our system one, yes. See if we can figure out where this string is. It's not useful. Very good, I guess. I guess we need more. Interesting. So is identity mounted in let's see, does identity make sense? Identity makes sense to mount, I think, right?
Yeah, I was wondering this, but then we saw that there's no type for it.
It could just be that it's the exact same, like maybe
Yeah.
I mean, sys definitely changes behavior based upon whether or not it's mounted in root or in a namespace, because there are paths that we filter out from being able to be called in a child namespace. And I assume the same is true of cubbyhole, perhaps. So maybe it really makes sense just to call this required mount table on a context.
So
And
this just has cubbyhole and identity, right?
it also has sys in here,
Oh.
this mount. So what we could do is we could say context. Return an error.
Yeah, that could be a good solution.
But this error was context was nil, which is weird, but we could also do this. Namespace error from context. That's right. Yeah, okay. So we should probably also return these as errors. And then we'll just update our caller to panic for us. Few more here. And so that also handles then injecting it into the running uh, mount table at the same time. Is we can just call it here. Required mount table. So let's see, do we still need this updated namespace? But if this error is oh, actually it doesn't, rather. Because table is a fresh mount table here.
Yeah,
So
I think this one is side effect free.
Yeah, this one is side effect free. So we'll call this entries table. Error is required mount table. And as context. And then error not now. We can return error. Space. Something, right? Yeah, we'll probably want to distinguish that. And so then this is a ns.core.required mount table in the namespace context. And then what we need to do is forget where this was. Mount entry. We need to do this. And so what happens here is not here. in this function in namespace store, we've already populated our namespace entry, I believe. Or entry is our internal copy, so we probably need to clone the namespace first. Clone entry one more time before handing it back to the mount table. But we can deal with that. Cool. And so then what happens down here is in cubbyhole mount and in all of these, if ns is not nil, the cubbyhole mount dot namespace ID is ns dot namespace ID. And then all of these. Let's see, so that's namespace ID, and then we have namespace itself. Use an S, will do the same for this, and then also for identity. Cool. And then up here, probably we want to say if ns is nil, ns will be our namespace, root namespace object. And that will handle that. And then I don't think there's anything else that needs to be set.
Maybe the type depends on whether we care to send the customized one, or if it's fine, we just keep the default.
Yes, that's probably good. So I think then what we actually want to do is we want to go up here like this. And set this on the mount itself. Like so. And like so. And then you're right, we probably want to go do that. So if ns dot namespace dot ID, yes, is not namespace dot root, namespace ID, cubbyhole mount type is mount. What was this? Type ns cubbyhole and type ns. This is sys mount. Sys system. There we go. Cool. That looks nice. And so then what we can do is here for entry, and this is not table, but this is mounts. This is I'm not sure we'll call this mounts. Entry mount mounts entries. We can then call ns.core.mount with namespace context. Right. Oh, but this calls, this prevents us from doing.
So we call mount internal directly.
Yes. So we'll call mount internal directly. So we'll call this then. Mount entry. And we probably want to call it namespace context. And then I think mount internal handles locking for us. It handles getting the namespace. It updates that actually for us. We don't really care here as much that we did it, but we did it for safety, for consistency rather. Ensure the cache is populated, fine. We don't really need that. TBH. Because we don't actually cache it that way. Cool. I think that's good. Very good. And so then that should then write this. Let's see. Let's see, where did we take this Boolean in? Update storage. Yeah, if update storage persists that now. Okay, so then we're handling that right accordingly. Cool. And so then if we do the same as well now, we look at auth.go, we're looking for token. Default auth table. So we're going to make the same change over here. Context, we're going to take this, return an error. If I save that. Oh yeah, I saved that. Mountain table error, we want this stuff, these goodies. And then we decided for safety, we were going to add namespace here. Let's see, namespace was ns.id and namespace was ns. And then this is going to be our format replacement. And that. And then namespace.id was not namespaces root, namespace identifier. Then we wanted to say type mount token type was mount type ns token. Nice. And we'll do the same up here. Auths, credentials, what they call plural form of this. And this is required auth table with this ns context. With this. And this is internal is enable credential internal. The reverse form that this one is. With the namespace context, the credential. And whether or not we write storage, which we do. So I guess you can mount arbitrary additional token namespace stores, if I read that correctly. Because there's no singleton. Oh, here we go. And show the. I see. Very good. Cool. And that's that. So that should handle our creation of mounts now. And so if we were to build this, it should probably fail to build because I'm sure we need to handle the return types from paths somewhere. Exactly. 581. Oops, 581 in this file. Good, we got a context there, default off table. Sure, we've got a context lying around here. There. There's not nil. And there's that error. Blue. Ugh. I kind of wonder if we should change those to actual return errors, but problem for later. So 1897. If there, I got the wrong type of brace there. Cool. See what that does for us. Cool. Error here. So we have an error somewhere. Yeah, we got an error. So namespace ID 1894. Oh, I see. So then they also in this version spin up default auth table, and this is required auth table, so we could make this default mount table or something, I suppose. But it doesn't really matter because we don't really want this. Blue. Remember those builds? We still have what to choose. Then about namespace. This is just ID. That's fine. Space 15 is ID. Then did I do that wrong over here? Default off mount. Namespaces ID. I did that one correctly here. 259. It's the namespace dot path. Namespace dot path there. 47. This is ns dot core dot mount, and this is ns dot core dot enable. That might actually work. Let's see where we're at. No, I think in modifying all of this, we've also broken some tests, but we can deal with that later. So, cool. So now let's see where we're at in terms of actually getting a mount table. And I guess as usual for anyone who's new, there's a project called DevBao that's under the OpenBao namespace on GitHub, which handles starting OpenBao for a bunch of different environments and stuff. It supports auto initialization and supports profiles. It doesn't yet support Postgres. So if anyone wants to add Postgres support with the containerized environment, I think that'd be cool. But not yet got there. But yeah, so I use that. So bao namespace create, I guess. And if we list NS1, oops, too many arguments. We got our namespace. Secrets list. That's fine. No handler for route sys mounts. Interesting. That seems slightly problematic. If we then look at core mounts, because we've not done the writing yet, right? So we have one namespace. This is NS1. And so if we come back here and look at this, oops. So that's an identity. This is pkint, which I guess I should probably remove. And that's sys. And if I were to field value and JQ it, namespace ID is root here. Do we not should call create mounts? So maybe create mounts is not 1%. This might be it. We didn't plumb through our error. So I suspect likely we had something in our log. Yeah, we don't have any messages saying that it mounted the namespace or mounted the thing. Let's see, let's get rid of our additional profiles. Let's do that, create our namespace. Plugin not found in the catalog, NS cubbyhole. Cool. We're making some progress.
I see.
So we need to do the so set core backend. So this needs to be case mount type namespace system. In case namespace cubbyhole. And case mount type, I guess identity isn't. And then mount type token. Empty that type. Equals mount type ns token. Well, let's try that. I don't know if that quite does what we want. Because I think that comes from plugin not found in the catalog. But you might need to modify the plugin catalog as well. Let's see. Rip. 217. Calls new policy store context. Base view is system barrier view. The policy store X. Context core. System logical system view is nil. Or base view is nil. System barrier view. Why would system barrier view be nil?
Might have been in the switch statement we modified earlier.
Must be. Not type NS. Oh, no. Thanks. I got my syntax wrong. There we go. That should be better. It was failing to set any system. Namespace. Nice eyes, Jonas. Which actually means I did not make the same mistake over here because this one's an if statement. Nice. Cool, that's that. And now if I create my namespace after loading my credentials, plugin not found in catalog still. Interesting. So that to me says set core backend is not called in the right place, and we still need to add it to the oh, if the type is not KB and it's not mount type, and then unknown backend type here. We might still also need to do entry.type is mount type NS system and entry.type not equals mount type NS cubbyhole. That probably needs to be done. So then if we come back over here, dynamic system view, this returns lookup plugin version, right? Let's see, I forget where we actually built this. Um, oh, here, this is probably the error that we're hitting. Logical backend. That's, here we go. Type namespace. Assume there's only one. Assume there's only one cubbyhole backend factory that we have here, and if we need to create another one, we'll create another one later. We'll do the assignment this way, I think.
I'm not sure the error even comes from the logical backends. I think it comes from plugin catalog.get, or is that interconnected?
You might be right there. But let's do that. That one doesn't exist. And then there should also be credential backends. So we want this one as well. But I suspect we'll need both places. Because that one's in shoot, where's that one? They call it registry. Built-in plugin registry, perhaps. No, sys isn't here. So I think it has to be.
Yeah, it has to be in there. I see.
Because these are the built-in, like the built-in ones, and the other ones are also. The other ones are also. The other ones are built in, but they go through the plugin registry. In the end, it makes me wonder if all the work to use the NS prefix to types are worthwhile or not, or if it's better just to detect it out of the context that we're running in a.
Do we have an idea of the benefit that might yield? Like that we are using it?
Clarity. It's the only thing I can think of. Like, I'm not sure it matters that much. TBH, but okay. So now we got that, and so now if we do our list, namespace one, we got some namespace type cubbyhole and namespace typed or namespace system type sys. So now if we do let's see what actually shows up in this. Well, I guess we could do this. Well, that didn't work. Right, namespaces NS1, policies. Policies. CL default. I don't know if that's quite true, but if I write have a policy lying around. No, I don't. Okay.
And you can use cubbyhole otherwise. Unless we want to test this specifically.
I wanted to test
Yeah.
this specifically. Yeah. This one might be. No, it's not useful. Path is, I don't know. Secrets capabilities is the policy is at. Now, if I list this, I read it, my policy, and now if I do the same without this, it still works because the policy store isn't yet made namespace aware. But it at least routes requests, and understands that there's a sys object mounted at that path.
Yeah, I think that was the goal here.
And so then secrets enable KB, and then secrets engines list, and then if I do enable path as secrets with namespace is as one, bao list as one KB. I do this. Custom value. Oh, right. I named this one secrets. And now if I list under metadata. Metadata. Oh, it's a KBV1 entry. Yeah. Not a KBV2. Cool. So that works.
Yeah, good enough.
And so now we have secrets routing as well also working. You can build a mount table, you can add them to the routes. What we haven't done, and depending on how much time you have left, or how much time you have, I'm happy to continue and get this finished on this, or we can open the pull request now and call it good.
I have time, no worries.
Okay, so then let's finish off the last little bit of this, which was that right now, if we look at mounts, right, and we read one of these, probably somewhat at arbitrary, we see that, right, this bao namespace lookup S1, right? You see that this KV entry for secrets is in the root core mounts thing. And I had wanted to push all of the data into namespace, under the namespace, right? Right, namespace slash UUID slash core slash mount UUID for that.
Yeah, I think we've agreed at this point in the working group that we want that layout, so.
Yeah, so that then you don't have any cross, like if you were to mount additional storage engines for each namespace, you don't have any cross namespace operations that you'll ever do. You'll always keep it within the box that is that one namespace. So what that means is when we go over here to do our namespace operations, we need to use a barrier view, or our mount table operations. We need to use a barrier view. So for persist mounts, oh, the other thing we should do before we get too ahead of ourselves is we should do dev-bao node seal prod, unseal prod, and see if this route actually persisted. Oops. Oh, I see. So there is a bug that's causing an unseal loop here. For post unseal setup failed, unknown backend type, and it's system. So we can't actually bring the cluster back up after sealing. So we should do that before we get to fix
I
that.
never should have brought up the types.
Yes. So where was that, do we think? Right here? So that was audit backends. No, that's audit backends. And so this should be ns underscore system, because this is entry type is not ns system type right there. So if it's not there, then perhaps it's over here. And of course it has that same check. Okay. Entry dot type now equals mount.
Maybe we can
NS.
later refactor this to have some global list available.
Probably. Would probably be the best option. And so then the question is, does that also, I guess that doesn't exist elsewhere. So, let's do. Yeah, we'll see if that does what I want it to do. I'm trying to make sure that we only get a single instance of these namespace versions within the namespace. And you can't just mount more like sys namespace things at a different path for fun. Also fix this one. Let's do the stop prod. I think that's not quite true. Resume prod. Till the nodes, unseal prod. See if it works. That's weird. Yeah. We'll do this instead. Start it fresh again. Cool. So create namespace one. Token credential backend cannot be instantiated. Because it's handled in. Well, one more time. Maybe this works. Because that also, I think, makes sense putting this singleton check here for the auth table, because it's the same for mount here, right? Protected mounts are protected and singleton mounts are protected there. So I think it makes sense to do a little more consistently. Cool, so bound node seal, def bound node seal prod. Unseal prod, see if it comes up. Get a permission denied there. That's weird. So it's status. So it's initialized and it's unsealed. Oops. But my vault token that literally was just working on this instance no longer works.
Does it work for different paths, like outside of the namespace?
No, because secrets list doesn't work.
Oh, well. Interesting.
So if I do dev bow node get unseal prod and then do a bow operator not generate, yeah, generate root in it and provide one of these unseal keys. Oops. Nonce is this. It's over here. And then I forget how I finish this. No, I'm confused. So I got this token. Oh, do I have to do it? Nope. Use the flag, the code flag to output the final. Oh, I see. And I want this too. There we go. So now if I export bulk token to this, interesting. Now this works again, and if I do I wonder if it has to do with mounting the token store.
Also what I'd assume at this point.
Yeah. Maybe core. Forget where this is. Token, I think. Because I only have this one token right now. Which is different than the root token that I just generated.
Is it the one from before?
Was this that was my original one. That's fun. So yeah, I suspect what we need to do is we need to make our namespace token accessor use the use the namespace prefix and start using that for tokens and stuff. So then this would be sys raw, well, namespace UUID sys token accessor for that namespace token instance. Though I am surprised. I'm really curious where we put that other token that we just created. Well, maybe it's under here. Could it be under one of these things? By chance? I don't know what that one is. Sys raw core names mounts. If I find, so that's the wrong system. That's the namespace system. That's the KB one. So one of these has to be such identity. Oh, that's weird. Oh, those are identity. Yeah. So then I need auth. Credentials. Let's see, where do we put that other one? No, that is auth. Yeah, okay. So then if I read this one, that's the main token one, and this is my other token one. And so if I look under sys raw logical, neither of these two UUIDs show up there. Huh. And that's audit backend, which I don't care about. It's different. Wonder where they went. Because this one, I think, was it this one? No, it was this one, I think. It looked an awfully lot like an auth mount. Yeah, that looks like the token I'm using currently.
Yeah.
So why is this, where does this UUID come from? Oh, it is, no. Oh, it's in this. Oh, that's tricky. So that's the UUID for this instance of sys within the namespace. And so it's dynamically fetching this sys copies path. So we probably want to fix that so that this copy of sys, uses sys as its path within storage, right? But just prefixed by the namespace itself. Cool. Okay, so still have time to
Yes.
fix
Let's
this?
see how to do this.
Let's finish
I'm
this.
barely following right now. But
Well, so what we've done, right, is when we brought up our second instance of our token, like, so, right, so we were trying to auth, right, and our auth got broken because we have two instances of the token service, one within the root namespace and one within the NS1 namespace. And for whatever reason, the root names, the token from the root namespace isn't getting respected because of, and is getting overwritten by the namespace specific token store, right? So like our root token that used to work up here or whatever, this s.0c was in our root token store, root namespace token store. And then this token that we're currently using that actually works because I did a root recovery operation is in the namespaces token store. And the namespace token store doesn't actually create a fat plugin instance, like with its own storage. It uses the system view to write. And because that system view is the namespace system view, it's writing to logical UUID, where this UUID is the UUID of the namespace, this namespace's sys instance, not the root's sys instance. And so it doesn't know about that token that exists in the root namespace store. It only knows about the one in the child namespace store. So we've got to do some, or not namespace store, token store. So there's separate work that needs to be done to fix the token store so that they're not global singletons, they're namespace aware singletons, right?
Yeah.
Singletons within the context of a namespace. And then when we take a token in, we have to go to the correct place to redeem it, which could be in the current namespace context or any parent namespace context. And so we have to recurse up through a couple of token stores to do. And so right now what's happening is we've loaded 2 of them, and the last one that loads wins, which is, in our case, the namespace specific one. And so that's why we had to do a root recovery operation to get a new root token. And so what I'd like to do is I'd like to at least update, because we're only concerned in this pull request that we're going to be doing with getting the mount table entries to align with the namespace storage. We're going to assume somebody else, maybe you, maybe one of your colleagues, is going to handle making the token store use the namespace storage, the identity store, the policy store, all that stuff, use namespace storage. So that's going to be a separate thing. We just care about getting our mount paths to be in the right place now. So does that make sense where we're at?
Yeah, that fits together.
Cool. So the thing I want to do is, I think I want, I'm just going to put it here. Right, so we have namespace entry, which can validate and can clone. I think we now need view, right? Any namespace entry view. Right, or something. And this will be I think we really just want to call this, right? And so this won't be that. This will be barrier, logical.storage. And then this will return a barrier view. And I guess it doesn't even return an error. Return new barrier view, and this is going to be barrier, and then it's going to be namespace entry dot and this would be paths dot join, and it will be namespaces. I think we're using, I guess we'll use namespace, and then we'll do namespace entry dot UUID. Right, and so this will give us the namespace specific storage path to write to.
I think it returns barrier view, not new barrier view.
Sorry.
I think it returns barrier view, not new barrier view. Yeah.
Yep. Thank you. So I guess probably what we should actually do before we get too far here is, well, commit it as a unit. So then we have, right, so in mount internal, we're going to persist mount, right? And so we need to decide how we want to persist mount, right? At the current point in time, we have a single storage engine. And so we can current point in time, we have a single storage engine, and so we can use a flat transaction across namespaces. And so I think we should make the smallest change possible and not start refactoring for multiple namespace, multiple storage engines per namespace. And so within persist mounts, we're going to right, we're gonna we're gonna handle this right by namespace. So down here, we call this the given namespace. I almost wonder if we want to separate out the namespace table somehow, right? Like should we do something like this long term? I guess that would be tough to maintain the migration for. Right, because what I'm struggling with right now is I can very much split this and use the barrier view for the particular namespace. In my transactional one, because it's writing separate entries anyways. So like I can go right here and say, any error is, I hope I have core. Yeah, I have core dot namespace store dot get. Let's see, what do I have here? Get namespace by accessor, and then my mount table entry dot namespace ID is here. And then if error is not nil, return one error, right? And I probably actually want to do this over here, right? And then the view is going to be what do I even have right here? I have barrier. So this would be any dot view over barrier. And then this would be view. And then if right. I don't actually have a list namespace entries. For item in range namespace. Like I think technically, strictly, this mount table for the legacy mount table should actually be flat like this, you know? Because we can't transactionally update that mount table. And so it needs to be flat. And so then what we need to do, so that's right namespace, and I think right namespace is correct now. And then if this is not present, this also needs to be view. And then this needs to handle this here. Right. Here. And this is present entry dot namespace ID, right? So I think that's that. And then we need to also update the load transactional mounts, right? And then this needs to be load transactional mounts for namespace. Right, and so then this function now will be core dot list namespace door dot list namespace entries. Context true. And then for we've got to so those are local entries and global entries. And so we only need to do this. Yeah, so this gets a little more complicated, I think. Okay, so let's keep down this route, right? So what we need to do is we need to list namespaces and then also handle what happens if we have no items in our list, right? So that's this case, and if we have local entries, we fetch and decode each local entry. So this mount table update will happen. up here. And so now all namespaces will be a list. We'll have global entries air be a bear that will be this would be click again. Right, so we're now listing all of our entries across all namespaces. And then global entries for if when ns global is greater than 0. Right, we're now coming back and putting them in global entries with the ns, with the namespace ID is ns global. Local entries, do the same thing for local entries. Is this making some sense?
Yeah, I think so.
And so now we have a list of all of our entries across namespaces. And so we know whether or not we've initialized our mount. And so then this will be a Boolean up here, I'm sure, that we'll need to keep as well. And so now we'll say, if we have no entries, we'll now do this portion, right? If we have no global entries in this map, we know we don't have any in any child namespace, and so we'll need to add the default mount table. And then we'll persist and strictly shield. Right, our assertion is that global entries is empty if and only if there's only one namespace, the root namespace, right? If you've created a namespace, you've already initialized OpenBao at some point in time. And so you shouldn't have an empty namespace table or an empty mount table. You already should have written mount entries, or you've otherwise messed up your storage in some way that we can't help you with. And so we'll do that. We'll create our mount table. That will be nice. We need to persist it. Otherwise, we do this, we come back here and we say for every namespace, for every namespace and everyone right, we do that loop, we do this loop, and we say, right. Let's see, NS index. Save that, call this NS index. So then for each of our remaining namespaces, we grab the view for that one, we check out our global entries, that we're sure to have existed, or that we saw on our earlier list for that particular namespace. We decode that particular one using the view, not the barrier. And then we do the same thing down here for local transactions or local entries. And this again uses view. Does that make sense? Have I
Yeah.
forgotten anything? Like I could probably
We'll
refactor
find
this.
out, I think.
Yeah, I could probably refactor that so that method comes back and we do this loop nicer somehow, but I don't think it's gonna be much prettier than this. And so what we're gonna have to do at some point later, right, is invert this transaction type and move the transaction into each namespace and grab a global transaction view per namespace in the future at some point when we use that. But in the meantime, we have issues because this is a map of string to string, and that needs to be a map of string to list to string, and probably some other issues as well. Not use UUID. This needs to be local entries dot ns dot namespace dot ID as well. Down there 1609 namespace entry. Not enough arguments and calls to get let's just context. Context. Present entries. So then this needs to be list all present entries and remove any deleted ones. Current entries present. This would be mount entry. This is here. If present continue, then this would be mount entry. That. what is current entry anyways? Oh, it's a struct. Current entries. This would be current entry. And that will store a little more memory, but won't be too bad. And we need to use barrier. Probably just do new barrier view. An empty path for the root namespace. Let's see if this. So I know, let's see, so this won't be able to work. Like our existing instance will need to be deleted and recreated anyways, because we'll now be looking for the mounts in the wrong paths rather than what we wrote them to. Cool, that builds. It's a good sign. The other interesting question is, if we run our vault tests, how many of them fail immediately? Oh, there's a couple of them. Failed to list audit devices. Well, that's fun. So we got an issue in mounts here. Load transactional mounts. Here. Service debug. So load transactional mounts 1257. Oh, it's a that would make sense. And then in auth tester mount test, we have issues. We can clean up well those. We see what this does. Cool, so that started. And so now if I do this namespace create ns1 and do a bao list sysraw, I should now have a namespace with an ID, which is a little interesting. So I guess maybe I need to modify my view to include trailing suffix there would probably make sense. I'm honestly surprised that that didn't just happen automatically. Oh, because it doesn't use. Oh, look at that. Let's try that. That might work a little better for us now. Gotta love it. Did you see that? Or was that too fast?
I think it was a bit too fast.
Oh, sorry. So in new barrier view, right? We created it without, right, you call logical new storage view. And logical new storage view takes in this prefix, right? And if you look at where prefix is actually combined, right, with your internal prefix, it's called expand suffix. And previously, if we look at the diff, it was just simple string concatenation. And so if you didn't include a trailing slash delineation on your prefix,
Oh,
you
yeah.
would get weird behavior. And so if you go back here, you should probably actually, explicitly add in your suffix somewhere there. But that's fine. Nice. There we go. Build this from scratch. Come on. Load that. Create the namespace. Look at sysraw, look at namespace. See our nice new namespace section that has a core and mounts, and it has 2 mounts. One of these is going to be sys. And so that's nice. Cool. And that is our identity store. And if we look at our other one, this one will be our sys namespace system. And if we come back through to core mounts, we have, again, only 2 items. And if we do a bao list, secrets list, I guess we have 3 items because we have cubbyhole, which doesn't actually show up as a stored mount table entry. And if we go namespace is ns1, we'll again see our 3 items. So we're good.
Should we test stopping and starting the node one more time? Just to...
Well, we know that that is still broken because we still haven't done any token store enablement for.
Okay.
Right. And so that's going to be another problem for another person to open a pull request for. Either yourself or Andre or one of your colleagues. But now you have this, right? You have this namespace entry view construct. And so when you're in that particular cubbyhole or in that token store or in that sys view, you'll be able to reference this view, which will give you the namespaces
right.
sys
Okay.
view version. So you'll have some more tools around. Cool. Well, I'll clean this up a little bit before proposing it as a pull request, but that was the bulk of the code changes. So did you have any more questions?
I'll be through.
That?
I'll probably have some more questions when I look at the full diff. Hard to follow exactly what we changed.
Yes, there was
so I'll come back there.
a lot going on, but no, I think this was very good. This was a bit longer than expected, but such is coding sometimes. So
For sure.
cool. Well, have a good one.
You too.